Okay, now you all got to pay closer attention, yeah, because this is a new thing. Thank you. Piecewise function. This is new one. Sorry. Piecewise function is new. Why you keep zooming? Okay, it's new. Now, I'm going to use an example to illustrate what we mean by piecewise function. Let's take a look at this expression here. Look up. What it means is this. Usually, the question only says, oh, okay, y sketch y equals x squared like that. But now it's very interesting. You sketch the graph of y. Now, y has 3 parts. Okay? Y has 3 parts. Now, interpret it. I think we are capable of doing it. What they're saying is now, if x is smaller or equal to 2, y is equal to 2. So what's good? That means, don't need to copy. What we are saying is 2, 4 like that. So for this part of the graph, from y, x be smaller than 2, y is actually 2. Just a straight line. So what's good? Now for 2 to 4, y is defined by y is x squared. So we have a curve here. From greater than 4, you have a 16 here. So this is what we call piecewise function. It is made up of 3 pieces. So far so good. So now we're going to practice using the GC to help us sketch the piecewise function. It's very powerful, really powerful. Okay. For some of us who cannot see this function, which I'm going to show you, it means that your GC is not upgraded. You should have your OS operating system of the GC. The GC is so powerful that it's got operating system like Windows 10, Windows 7, like that. So the way to test whether your GC is properly upgraded is this function already. Okay? But even if you don't have, not the end of the world. Okay, I will show you how to do it. But not here. Okay, after class you can't find it. Okay, so how do we do this? Let's clear this. Let's go to this screen, y equal. Let's go to y equal screen. Can we do it together? If you are lost, you can look here to see what I key in, okay? So first I press y equal to go to this screen. Now, we're going to copy what we see in example 6, okay? Alright, example 6. So, you're going to have wait, what do we get? This is my own notes. Sorry. Then, never mind, it's okay. You go to math. Then you go up, press enter. Okay, up, you press enter. Now, you are telling the GC that I want to sketch a piecewise function. Then the GC asks you this question. How many pieces do you want? Okay, you want 3 pieces. Because you want 3 pieces. Okay? Don't have this function, that means your GC not upgraded. Then you see this. Okay? IP students probably not upgraded. Yeah, never mind, can be done one. Can upgrade. Just find your tutor or find me, have a table, then we can upgrade. No problem. Okay? Now, there you have this. Then what you need to do is just key in what you see. You have 2. Right? Then you key x smaller equals to 2. X. How do you key in? How do you find the menu smaller than or equal to? It is under test here. Second math. Then you want smaller than or equals to, which is 6. 2. Then go down. Then go right, left, sorry. Then you key in x squared. Then you key in your V2 second test smaller than, which is 5, x second test 5, 4. Then go down, and last piece you want 16, and you want x second math. How many of you is lost? How many of you are lost? Okay, greater or equals to 4. Now, all got this? Okay. Those of us who have the UGC, okay? Yeah, follow? Then what we need to do is to zoom. Usually, by default, we always put zoom 6. Then you see this thing. But interesting, you only see one piece. You only see 2 pieces. Where is the third piece? Do we know why we cannot see the third piece? Because here you sketch from minus 10 to 10, minus 10 to 10. But actually you want to see 16. Correct? You want to see your 16 is up there. So what do? We go to window, press window, window, press window. Then you tell the GC, hey, hello, I want to see bigger, I want to see the Y, I want to see 16. This Y maximum is something wrong. So I want Y minimum, no need to be minus 10, just 0 will do. Then this one you put 18, whatever. Okay? Then it looks good. Then you press graph. There you have it. All good? Can? Okay, Okay, let's now go back to the notes. So these are all the things that I just said. Blah, 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 blah. You get this. Okay? Or you see, now this is what you see. What I did was, we just change. I only changed the 10 to 28. So, now, what are you going to sketch on your script now? Okay, what are you going to sketch? Wow, now it's a problem. I need to draw a straight line, and I have no ruler on the tablet. Pardon me if I don't draw a straight line, okay? You know what? Draw a straight line. So, you know that from okay, this is a straight line. This is a straight line. Sorry if it doesn't look like a straight line, but this is a straight line. From 0 to 2. Sorry, from this point is 2, 2. Because all the way from x, from negative infinity to 2, the y represents, the y is a straight line. You use ruler, don't use ruler. I don't have ruler. Now, what do you see on your GC? You see this on your GC. Now, the tempting thing to do is to draw a straight line here. But actually it's not a straight line. It is a quadratic graph. Y is x squared. But the GC make it look like a straight line, but actually it's not a straight line. So you don't draw a straight line. Okay, we don't draw a straight line. We then have to draw a curve. Now the curve is very interesting. If you take a look at the expression here, if you sub x equals to 2 here, you will get 4. The y coordinate is 4. So there is a discontinuity somewhere because it makes sense. You look at your here, there is a discontinuity somewhere. Meaning when sub x equals to 2 here is, maybe I zoom in. Sorry. This point is 2, 2, which I just sketched. Correct? Whereas with the moment you hit 2.01, if the x coordinate is 2.001, then you have 2.0001 squared, you get some number that's close to 4. Does it make sense? Yes? So, to represent that, sorry, you will have to have a 2, 4 here. There is a discontinuity. Then you have a curve like that. Maybe I draw a bit nicer. 2, 4, 4, 4. Let's be a bit more proportional. Okay? This has to be a curve. From 2 to 4, this has to be a curve that goes upwards like that. Then finally, when x greater than 4, you have a straight line like that. And this is 4, 60. Now, how do we know all these coordinates? There are two ways to do it. One, you work it out on your own analytically. Two, you can actually use your GC to help us. You can actually use your GC to help. What do I mean? Okay, I pause for a while. For us to copy. Okay? All good? Now you can use your GC. How do we use your GC? You actually can do this. Let's press, let me clear this tree here. You can press trace. Then you press 0. Enter. What it gives is when x is 0, y is 2. So actually you also need to label this one. Sorry, I forgot. You also need to label this one. The coordinate is 0. Or you also need to label this one. Alright? Now, then next you can actually trace and say what is when x is 2, what is it? What do I mean? That means press 2, enter. You get no, when x is 2, y is 2. The unfortunate thing is you can't find this one, the 2, 4 coordinate. But you can pretend, you can say 2.0001. Then enter. Then you get 4.0004. That means it's very close to 4. So far so good. Then you put what is 4, enter, you get 4, y is 60. Got it? Yes? So, another thing I want to highlight is this. What does this open circle represent? This open circle is very important. This open circle represents that this point is not a point, 2, 4 is not a point on the graph. I want to exclude this point from the graph because when x is 2, y is actually 2, y is not 4. If you look at the expression, the piecewise function definition here, sorry, let me go up a little bit. Let's look at here very carefully. When x is 2, y is clearly 2 because this inequality sign is strictly greater than. Follow what I'm saying? Yes? So you don't look at 2 here, but it's 2.001, then you use this definition. So you have to have an open circle. Can? All good? Okay. Very good. Okay, example 7. Okay, I need to pause the recording.